Okay, we're going to be making a big transition from Chapter 7 to Chapter 8. In Chapter 7, we assumed that we knew the true value of the parameter and then asked questions about the distribution of the statistic used to estimate the parameter. For example, we would be asking questions like, assuming mu was 10, what is the probability that x bar is greater than 12? So we assumed that we knew the population mean, and we were trying to find the probability or estimating the probability of that happening in our sample. In Chapter 8, we're no longer going to pretend that we know the true value of the parameter. We start with a more realistic situation where we know only the value of the statistic. Because really, when we're doing statistics, and we're going to know our sample mean, and we'll have to estimate what the population mean is. So, Chapter 8, we're going to start doing that. So we're going to start with the value of the statistic and estimate the value of the parameter. So we'll be asking questions more like, if x bar, or our sample mean, is 123.8, what are the plausible values of our population mean, mu? Okay, so what is a point estimate? A point estimator is a statistic that provides an estimate of the population parameter. And it could be the sample mean, it could be the sample deviation, it could be the sample proportion. But it has to be the sample statistic. And so what is the point estimate? Point estimate is a statistic that provides an estimate of the population parameter. Like I said, it can be a sample mean, it can be the sample deviation, it can be the sample proportion. And why is it called the point estimate? It's called the point estimate since it represents a single point on the number line. The value of the statistic from the sample is called the point estimate, and it's the best guess at the unknown parameter. Point estimates are never perfect. They always have an error component. This is commonly referred to as the margin of error in both statistics and popular culture. And we're going to be talking about the margin of error on the next page on this. So what is the logic behind confidence intervals? Now, here's the thing. When we're talking about statistics and we're talking about what we estimate as our true mean, we might say something like the polling in the U.S., say 50% of the people agree with this statement in a poll, and they say plus or minus 3%. That's the margin of error, that plus or minus 3%. Technically, the error component is expressed as a confidence interval, and we're going to be talking about that too. So what is the logic behind confidence intervals? Well, the mean of the population is probably not the exact mean of the sample, but we can estimate the population mean within a certain interval, and that's the logic behind it. So what is a confidence interval? A confidence interval for a parameter is the interval calculated from the data which has the form estimate, your estimate, whatever your estimate is, plus or minus your margin of error. And what is the confidence level? The confidence level gives the overall success rate of the method of calculating the confidence interval. I'm 95% confident that my estimate will be within plus or minus my margin of error. So what is the margin of error? It tells us how close the estimate tends to be to an unknown parameter in repeated random samplings. So if we sample over and over and over again, this margin of error is going to tell us how close we are going to be to that unknown parameter, either our mean or our standard deviation or the proportion. Why do we include the margin of error? The statistic is rarely the actual parameter, so we can only come close to the actual value of the parameter. The margin of error tells us how close we are. So how do we interpret a confidence level? In other words, what does it mean to be 90% confident? To say that we are 90% confident is shorthand for saying 90% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. And how do we interpret confidence interval? Okay, to interpret a C% confidence interval for an unknown parameter, we say we are confident that the interval is from some number to some number, which captures the actual value of the population parameter in context, whatever we're talking about. Now, be careful. It's the AP chat. Be careful not to confuse interpreting confidence levels with interpreting confidence intervals. They're not the same thing. So let's take a look at what we're talking about. This is the density curve here, and here's our population mean. If we take one single sample, our single sample confidence interval may or may not include the population parameter. Take this one for instance. It's outside of the population parameter. Since here is our mean is not going to fall within this interval. But if we take many, 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 many samples, each one of these being a sample, then 95%, what we're saying, if it's 95% confident, that in the long run, that 95% of our confidence intervals, will contain the true population parameter. If we're using 95% confidence level, if we're using 90, then we're talking about 90% confidence interval. Okay, so be careful. Every time you construct a confidence interval, you're expected to interpret the interval you calculated. You're expected to interpret the confidence level only if they specifically ask you to do so. So, according to www.gallup.com, on August 13th, 2010, the 95% confident interval of the true proportion of Americans who approved of the job Barack Obama was doing as president was 0.44 plus or minus 0.03. Interpret the confidence interval now, and the confidence level. So let's take the confidence interval. Okay? We are 95% confident that the interval from 0.41 to 0.47, 0.41 meaning minus 0.03 and 0.47 meaning plus, captures the true proportion of Americans who approved of the job Barack Obama was doing as president at the time of the poll. And then our confidence level, 95% of all possible samples taken at the same size, the resulting confidence interval would capture the true proportion of Americans who approved of the job Barack Obama was doing as president. So in the confidence interval, you're giving your endpoints, and in the confidence level, you're not. So keep that in mind when you're doing this. Okay, so now would be a good time to stop and check your understanding. How much does fat content of Brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 Brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. Interpret the confidence interval. Okay, we are 95% confident that the interval from 2.85 to 7.55 grams captures the true standard deviation of the fat content of Brand X hot dogs. Interpret the confidence level. 95% of all possible samples of Brand X hot dogs, the resulting confidence interval would capture the true standard deviation. And true or false, the interval from 2.85 to 7.55 has a 95% chance of containing the actual population standard deviation. Justify your answer. False. The probability is either 1 if the interval contains the true standard deviation, or 0, that's supposed to be a 0, if it doesn't. So make that a 0. What is the formula for calculating the confidence interval? Is it on your formula sheet? It's your statistic plus or minus the critical value times the standard deviation of the statistic, where the statistic we use is the point estimator of your parameter. And is it on our formula sheet? Yes, but you will have to know how to use it. How can we reduce the margin of error in a confidence interval? Are there drawbacks to these actions? Okay, you can increase the size, your sample size, but increasing the sample size is often costly and time consuming. So the bigger your sample size, the smaller your margin of error. If you increase your sample size, you decrease your margin of error. If my N was 320, I would have a big margin of error, where if my N was, my sample size was 1280, it would be smaller. But again, it's going to be costly and time consuming. You can increase your confidence level, but then you increase your margin of error. So the smaller the margin of error is good, because we get a smaller range of where to expect the true population parameter.